Hi, and welcome to Lesson 27, word problems leading to rational equations. So yes, it does say word problems. It's going to be okay. Let's dive right into it with some word problems. So we've got a bunch of people painting a room. We've got Sam, Jenna, and Francisco. Sam can paint one room in 6 hours. Jenna is much better at it. She can paint one room in 4 hours. We don't know how long it takes Francisco to paint a room. When they're working together, they can paint a room in 2 hours. So they can do one room in 2 hours. So let's set this up. Hey, if Sam's working alone, that means that he can paint 1/6 of a room in 1 hour, right? If he can do one room in 6 hours, that means that in 1 hour, he can do 1/6 of a room. Also, Jenna can paint one room in 4 hours. So that means that in 1 hour, she can do 4 rooms. Sorry. In 1 hour, she does 1/4 of a room. And we don't know about Francisco. So Francisco is our variable. We're not sure about his rate. All right, we know that altogether it takes them 2 hours to paint one room, which means that they could paint half of a room in 1 hour. So now each of these things are set up in terms of 1 hour. All right, so we have to find a common denominator in order to solve this thing. All right, so the smallest number that is divisible by both 6, 4, f, and 2 is going to be 12. All right, so I'm going to go ahead and multiply this whole equation by 12f. So I have 12f over 6 plus 12f over 4 equals 12f over f. Sorry, plus 12f over f is equal to 12f over g. And that's going to give me 2f here, right? 12 divided by 6 is 2. And 3f here. And then 12 here. And this gives me 6f. So let's go ahead and combine my terms over on the left. I'll end up with 5f plus 12 equals 6f. And now it's time to subtract 5f from both sides, and that will give me f equals 12. So it turns out that Francisco see, how long would it take Francisco to paint one room on his own? It is going to take him 12 hours, okay? So it will take 12 hours. Man, Francisco is not very good at painting. Either that or like he brings all his homies with him to paint and gets nothing done. Who knows? It takes him a long time to paint a room. All right, so there it is. Hey guys, make sure always that when you answer a word problem, since you're being asked a question in words, your answer should also be in terms of words, right? You should answer with a sentence. Let's do another one. Julie can mulch a garden in 20 minutes because she's quite a woman. Together, Julie and Remy can mulch the same garden in 11 minutes. How long will it take Remy to mulch the garden when working alone? All right, so Julie can do a whole garden, right, in 20 minutes. All right, so we've got Julie's rate plus, we're not sure what Remy's rate is, right? Is going to be equal to their rate together. So our common denominator would be 220x. So that means that I need to multiply this whole equation by 220x. So that'll give me 220x over 20 plus 220x over x equal to 220x over 11. Okay, when I divide this, I should be left with 11x here. When I divide this, I should be left with just 220. And over here, I will have 20x. So I'll go ahead and subtract 11x from both sides. And that's going to give me 9x. Divide both sides by 9. And I get approximately 24.44. So what do we say? We would say that it takes Remy approximately 24.44 minutes. Fantastic. We got a couple work problems and done. Let's check out another one. All right. It doesn't seem like a work problem, this one, but it is. We're talking about a bathtub being filled in 8 minutes. It takes the tub 12 minutes to drain. If the tub has the faucet on and the drain open, how long will it take to fill? Who knows why you would do such a thing, but one might. So, actually, you might do something like a better problem for this would be something like pumping air into a room, right? The air's got to escape, and you're probably pumping in a little bit quicker than it escapes. But anyhow, let's go ahead and get to this problem. So the bathroom is filled in 8 minutes. So our rate for the bathtub can be expressed as 1 over 8, right? Because you can anyhow, sorry, we're subtracting here when we're draining the tub, right? So 1/12 of the bathtub gets drained in 1 minute, right? And 1/8 of it gets filled. Sorry, and 1/8 gets filled in 1 minute. So here we go. We want to know how long it takes when we work together, right? So we've always got a rate number 1, and then rates 2, and it's always going to be equal to the rate together. All right, so now we'll go ahead and solve this. The common denominator that we would find for these would be 24x, right? That's the least common multiple of 8, 12, and x. So let's go ahead and solve this thing. I'm going to have 24x over 8 here, minus 24x over 12 equals 24x over x. Let's solve this thing. So this is going to give me 3x when I divide. 24x divided by 12 is going to give me 2x. And over here I will be left with just 24 because my x's will cancel. So that means that x is 24. So in context of this problem, right, we always got to answer these in context. How long is it going to take for this silly person who is trying to fill the bathtub with the drain open? It will take 24. We got to make sure we have our units right. It's 24 minutes. Perfect. Moving right along, let's do something a little bit different. So now we're going to deal with distance problems. Okay, so with the distance problem, we're always going to rely on the fact that our distance is always equal to our rate times our time. So we're always going to be setting up equations in terms of distance, rate, and time. I like to set it up into two things. Okay, so in this case, we have a kayaker going upstream. And we can write an equation for this kayaker's distance, rate, and time as it goes upstream. So right away, it's easy to pick out that this is our distance, right? So upstream travels 2 miles. So my distance is 2. You got to figure when you're going upstream, you're going against a current, right? So that's going to have to come into play there. I also know that the total time, right, was 5 hours. In other words, the time that it took to go upstream, we'll call it T1, plus the time that it takes to go downstream, that we'll call that T2, is going to be a total of 5 hours, right? And those times have to be different because, of course, it's going to take a little bit longer to go upstream against the current than it is going to take to go downstream with the current. So now that we have that into play, it tells us that in still water, the kayaker can travel at an average speed of 2 miles per hour. So that means that when he's going upstream, he can do that 2 miles per hour, right? But that's going to be subtracted by the rate of the current that I'm going to call C. And that's going to be times time, and that's going to be time 1, which we said was our time upstream, right? So check it out. It takes 2 hours at this rate where we're going against the current, and we know, and we have this time, right? So that's our time upstream. I'm eventually going to want to plug this value of t in here. So let's go ahead and quickly solve this for t1. What am I going to do? I'm going to divide both sides by 2 minus c. So that's going to give me 2 divided by 2 minus c is equal to t1. There we go. Now I have one expression for t1 that I can plug in here. Now I need an expression for when we're going downstream. It's going to look really similar because we go 2 miles downstream, right? We're going 2 miles downstream. So the distance is the same. What's going to change when we're going downstream is that now we have the current helping. So went 2 miles, that's my distance. My rate now is going to change because I'm going to be going 2 miles per hour plus the speed of my current. And I know that this is going to be a different time because it's probably going to be faster. So now that I have that, I'm going to solve for T2. I'm going to divide both sides by 2 plus c, and it's going to look like this when I divide both sides by 2 plus c in the same way that I divided our previous equation. So there we go. So now I have an equation in terms of time 1 and time 2, and I'm going to go ahead and plug those into this equation that I set up for my total time. Okay, so what does this say? This says the time that it takes to go upstream plus the time that it takes to go downstream should equal 5, right? 5 hours. All right, well, now we've got to solve this thing. So what is our common denominator? And you'll see that also, before we get there, look at this. We're solving for current. And what are we being asked for? We're being asked for the speed of the current. So it's working out really nicely for us. All right, so our common denominator for this thing is 2 minus c times 2 plus c. So I'm going to go ahead and multiply this whole thing by 2 minus c times 2 plus c. When I multiply the first term on the left, my 2 minus c's will cancel and I'll wind up with 2 times 2 plus c plus 2 times, and again my 2 plus c's will cancel and I'll just wind up with a 2 minus c in my numerator, and then over here we have the whole kit and caboodle, 5 times 2 minus c times 2 plus c. So there it is. All right, we got to solve this thing. It looks like we might wind up with a quadratic equation in our hand. Let's see how this thing shakes out. Let's solve it. Here we go. I'm going to go ahead and do all my distribution. So I'll have 4 plus 2c plus 4 minus 2c. That's nice. And this is going to be 5 times. I'm going to go ahead and FOIL this thing out first. So I will have 4, right? So that's 2 times 2. And then I have a 2 times c, which gives me a positive 2c. And then I have a negative c times 2, which gives me a negative 2c. So those are going to cancel. And then all I have left is negative c. All right, let's combine like terms over here. These two are going to cancel. And all I have left over here is an 8. And I'll distribute my 5, and that gives me 20 minus 5c squared. Okay, well, I would really like, so I know because of this 2 here, right? That 2, that I have a quadratic equation. So that means I need to set this thing equal to 0. So I'm going to go ahead and add 5c to both sides, 5c squared rather, to both sides, and subtract 20 from both sides. So that's going to give me 5c squared minus 12 equals 0. I chose to move the 5c squared over rather than subtracting 8 from both sides, because I really would like my coefficient of my term that is squared to be positive. Okay? But this isn't factorable. So I'm going to go ahead and go backwards and add 12 to both sides. Divide both sides by 5. And then take the square root of both sides. Oops, that should be 12 fifths. So I'll put that into my handy dandy calculator real quick. And that gives me approximately plus or minus 1.549. And really, if we're going somewhere, it doesn't make sense for us to have a negative rate, right? So then we would say that the current is approximately it is approximately 1.549. And what were our units that we used? I believe it was miles per hour. Perfect. So we can say miles per hour if you wanted to. Hello. Or if you wanted to abbreviate that, that would be fine. All right. All right, so let's do another one. Again, a distance problem. So the main formula that we're going to use is that distance is equal to rate times time, right? Once again. And we have his trip going and we have returning, right? So when he's going there, we're going to write an equation for that using distance equals rate times time. So he drives 60 miles to the convention. So our distance then, 600 miles. And then what do we know about his rate and how long it took? Well, we only know that on the return trip he increased his speed by 10 miles per hour. So let's write this formula as well, just to try to find out what's going on. So if he went right back to where he came from, he must have gone 600 miles. And then his rate is increased, right? So whatever that rate is, it was increased by 10 miles per hour. All right. And then it looks like his time at that point is the time that he had going minus 2 hours. So it looks like now we have our distance equals our rate times our time. So what do we know about this? I think we just know that there was a rate and there was a time. And we're not sure what those values are. It looks like we're going to have to solve for 2 variables in this one. Okay, so in order to do this, I have to go back to my Algebra 1 skills. I'm going to have to solve for one of these variables and then substitute it into the other equation. So in this case, I'm going to go ahead and solve my going time for t. So if I solve this for t, I divide both sides by r, and I get t is equal to 600 over r. All right, so now I can be able to actually substitute that 600 over r instead of t in this equation. So I wind up with r plus 10 times, and now instead of t, I'll substitute 600 over r minus 2. We can solve this thing for r and then substitute r back into one of our equations to solve for t. So our first task is to solve this for r. So the first thing that I'm going to need to do is to distribute. So r times 600 over r. My r's will cancel and I'll wind up with just 600. R times negative 2 is going to give me negative 2r. 10 times 600 over r is going to give me a positive 6,000 over r. And then 10 times negative 2 will give me negative 20. And there that is. All right. So I really dislike that I have this r in my denominator. So I'm going to go ahead and be clever and get rid of it by just multiplying my entire equation by r. I really don't like that r is there. So I'm going to multiply this whole thing by r. That'll give me 600r equals 600r minus 2r squared, right? I'm multiplying everything. So negative 2r times r is going to give me negative 2r squared. When I multiply this by r, the 6,000 over r, those r's cancel. And I wind up with 6,000 and then a negative 20r here. Okay, well now we're able to do some combining like terms. Number one, and adding and subtracting from both sides. Or just adding and subtracting from both sides at this point, really. So I'm going to subtract 600r from both sides, and that's really nice, because that goes away. And I wind up with negative 2r squared. I'm going to go ahead and just reorder this. I want a negative 20r plus 6,000 here. I just want that to be in standard form with my r squared and then my r to the first power and then my r to the 0 power all in order. Well, I really don't like that there's a negative 2 as a coefficient of my r squared. And it looks like each one of these things is divisible by 2, right? They have a common factor of 2. So what I'm going to do is go ahead and divide everything by negative 2. Right? And I'm dividing the 0 by negative 2 as well. So that gives me the equation 0 equals r squared plus 10r minus 3,000. Okay, now I have two options at this point, or three really. I could complete the square if I wanted to. Don't really want to do that. I could see if this thing is factorable, or I could use the quadratic formula. I have a feeling that this thing is indeed factorable. I think that there are two numbers that if I multiply them, I get negative 3,000, but if I add them, I get positive 10. Those numbers are actually going to be 60 and negative 50. So that means that r is either negative 60 or r is 50, right? And this one right here, we got to cancel that one out because I don't know of anything like negative speed. There's no such thing as a negative speed. Speed is always positive, so there we go. So we know that r then must be 50, which tells me what? Tells me that this man, his rate is 60 degrees. So let's see. How fast did he drive? Sorry, 60 miles per hour. I believe actually that we have answered this question. We could solve for t as well if we wanted to, but we were asked for how fast, and we have done it. So he traveled 60 miles per hour. We decided that was 50. I apologize. He traveled 50 miles per hour going to the convention. And 60 miles per hour returning. Why? Because we said that he increased his speed by 10 miles per hour, right? Boom, done. I think we just have one more to do, and then we are done with this. All right. This one's actually intermodule as well. Melissa is walking 3 miles to the house of a friend. She returns home on a bike. That's shady. She averages 4 miles per hour faster when cycling than when walking. And the total time for both trips is 2 hours. Find her walking speed. So again, so when she walks, we're going to have some distance. It's 3 miles, right? So our distance is 3 equals our rate. We're not sure. And we don't know The total time for both trips is 2 hours. So she went faster on this one. So we'll call that time 1. All right. When she's riding the bike that she may or may not have, that she may or may have not stolen. I don't know. Wonder where she got a bike from. That's all I'm saying. All right. She actually goes faster, not only because she's riding a bike, but because maybe, I'm just saying, allegedly the bike was stolen. So she went faster. The total time for both trips, and we know that it had to have taken a faster time, right? So those times are not the same. We also know that the total time for both trips is 2 hours. So that means that the time that it took her to walk plus the time that it took her to ride should equal 2 hours. Sweet. So now we've got the same deal, right? I've got to solve each of these for time 1 and time 2. And then I'll plug them back in. So for walking, we've got, when we solve this, we have that T1. Right, we're going to divide both sides by R, so T1 is going to be 3 over R. For our biking, we're going to divide both sides by R plus 4. We'll get that T2 is equal to R3 divided by R plus 4. Now we can plug those right back into our equation. So we're going to substitute those. Instead of T1, I'll put my 3 over R. And instead of T2, I will plug in 3 over R plus 4. And now we got to solve it. It looks like our common denominator is going to be R times R plus 4. And that'll get that done for us. So I'm going to multiply this whole equation by our common denominator, R times R plus 4. And here we go. When I do that, all I'll have left here is 3 times R plus 4. Over here, 3R. And then this will be 2 times R, or 2R, times R plus 4. All right. So when I distribute this, I wind up with 3R plus 12. And I'll just leave this 3R here. And then 2R times R is going to give me 2R squared. And 2R times 4 is 8. Okay, 3R plus 3R is going to give me 6R. So just combining like terms over there on the left-hand side. And now I would really like to have everything over on one side and 0, right? On the left-hand side I'm going to go with. Right, we're going to set this equal to 0. So I'll subtract 6R from both sides, and that'll move that over here. And then I'll also subtract 12 from both sides, and that will give me a -4 here. Look at that. Each one of those 3 terms has a common factor of 2. So I'm going to go ahead and divide everything by 2, which will give me R squared minus 3R minus 2. Now, is this thing factorable? Is the question. Alright, we just have to take a step back. When I distributed this 2R, I got the 2R squared, but I missed that this should be 8R, right? So that's an 8R. And that's just going to change this up a little bit. Sorry about that. So when I set this equal to 0, now I'll have 2R squared, and I'll be subtracting 6R from both sides, which will give me 2r here, and then minus 12. So that's better. So I'll divide everything by 2, and I wind up with r squared plus r minus 6. And that's much better, because that actually can be factored. This is going to be positive 3 and negative 2. So that means that my rate is either negative 3, which doesn't make sense, or my rate is 2, which is great, right? That one, negative speed, doesn't make sense. So my rate is 2. So what does that mean in the context of the problem? That means that her walking speed, right, that's this one right here, was 2 miles per hour. And if we were asked, what is her speed on the bicycle, we would be able to answer that it was 6 miles per hour, right? Because the problem says it was 4 miles faster. All right, well, thanks so much. It looks like Melissa got away with stealing the bike. It's really bad, but I'm glad that you watched this lesson, and I'll see you tomorrow. Thanks. Have a great evening.